Okay, let's talk about some applications, aka word problems. So we're going to have two common kinds of word problems. Problems dealing with angle of elevation. Angle of elevation is when you're looking up or going up. Angle of depression is obviously going to be looking down. We'll get to that. So let's talk about a problem here. All right, so Sparky stands 200 feet away from the base of a building. So here's a building right here, and we're assuming right angles on our buildings and trees and platforms and all that kind of stuff. Sparky stands 200 feet away from the base of the building. Sparky looks up with an angle of elevation of 35 degrees. So he looks up, and the angle of elevation of looking up, because you think about it, see, Sparky's line of sight is straight ahead. If he's looking straight ahead, and then looking up, his line of sight is now up 35 degrees. So straight ahead, 0 degrees, line of sight, turns to look up. So 35 degrees is now his line of sight. So he looks up, he's got a 35-degree building. Sparky's 4 feet tall. What's the height of the building? So I look at my information here. He's 200 feet away. I got a 35-degree angle. I need to know the whole height of the building. Well, it says that his eyes are 4 feet above the ground, so we put that in there, 4 feet. So what do we have here? 200 feet away, I've got a missing piece, and I know I've got 35 degrees. Hey, wait a second. That 35 degrees, that's missing side right there is opposite to 35 degrees, and that 200 is adjacent to the 35 degrees. Why, that sounds like a tangent. Sounds like tangent of 35 degrees is equal to that h over 200, which means little old algebra here, cross multiply 200 times tan 35. So let's see what happens here. 200 times tan 35. So we get 140.042. If we round to the third place, 140.042. So then you'd say the total height, well, you still got that 4 feet right there, if you consider in Sparky. So 144.042. And since our units are feet. So I don't need to repeat all that. You can go back and watch it because it's just about, I looked up the height. We set it up. Hopefully you're thinking, oh, that's no big deal. Okay. What about something like this? Angle of depression tends to be a little bit trickier. Angle of depression tends to just be a little bit trickier because you're looking down. Okay, so Susie is looking down from the top of a building at a dog. The angle of depression of her line of sight is 37 degrees. If Susie is 500 feet above the ground, how far is the dog from the base of the building? And once again, we're assuming right angle. So the dog, here's my dog, and here's Susie up here. Okay. Now, here's the tricky part. The angle of depression is 37 degrees. Where does the 37 go? Okay, this is the tricky part. All right, if Susie's looking straight ahead, this is her line of sight. She's looking straight ahead. There's her line of sight parallel to the ground. Line of sight parallel to the ground. So she's looking straight ahead. Her line of sight is parallel to the ground. Then here's her line of sight. Then she looks down at a 37-degree angle. She looks down at a 37-degree angle. So it's like, the 37 degrees is actually outside of the triangle we want. See, that's what makes angle of depression a little bit weird, is that you're going, oh no, the 37 degrees is actually on the outside of my triangle. What am I going to do? We got a couple of choices. You could say, oh, this is no big deal. If that's, like I said, her line of sight is parallel to the ground. So if that's parallel to that, then if that's 90, this has to be 90 up here. So 90 minus 37 would make this angle. Or if we remember our really groovy rules from geometry, you could say, wait a second, if these are parallel, that makes this guy a transversal. That makes this a transversal, which means these are alternate interior angles, and the alternate interior angles would be equal. So either way you look at it, you end up in the same spot. And you're saying, what spot? I don't even see what you're talking about. All right. If you said, well, they're alternate interior angles, so they're equal. So that'd be 37 degrees. Okay. So now I've got an angle and I've got enough information. Or you said, no way, I wanted to do this. I wanted to subtract and make that 53 degrees. So we've got two choices here. You can say, oh, if I do the 37, I can say tangent 37 equals 500 over x, 37. So that's opposite and adjacent. Somebody else says, no way. I'm going to do tangent 53 is equal to x over 500. Here's my 53, so that'd be opposite hypotenuse. So you got two different ways to do it. So, all right, so remember algebra, you can say, well, this one's a little messier because you have to cross multiply and then divide. So you'd have x is equal to 500 over tan 37. This way would be a little bit easier because you only have to do one step. Cross multiply the 500, so 500 times tan 53. And then I know there's some of y'all are just not going to believe this just doesn't make sense. How can this be? Let's prove it to ourselves. Let's prove it. 500 divided by tan 37, 663.522 feet. And then say, yeah, there's no way. This is messed up. This is not going to work. So wait a second, it did work. It's the exact same answer. So as we keep saying, multiple ways to work these problems. And what I like to say is when you've got these angle of depression problems, the careless mistake is you put the angle of depression on the inside, up at the top. And it's not. The angle of depression's on the outside because you were looking ahead and then you look down. So the angle of depression is actually outside the triangle. You were looking straight ahead, parallel to the ground, you look down. So but then you realized, oh, wait a second. They were equal. It was equal to the angle of elevation because of the alternate interior angles from geometry. So just throwing that out, you can just always do that. Say, oh yeah, I can just make them equal. If they give me the angle of depression, I can just turn it into the angle of elevation of the other piece. Okay. So that's just one way to look at it. And then I got one more problem.